Hello guys, welcome to our class. So our class today is time series analysis. So I hope can hear me clearly. I just want to jump in direct because we don't have time. So we talk about time series analysis. We tend
na kabla sijajibu maswali sana, ningependa kukosoa ndugu kusema hivi na kwamba sio William Samuel Ruto ndiye anayejibu sana. Na pia unafaa uelewe kisheria kwamba
so time series analysis. So on time series analysis, we shall talk about various items, and hopefully we shall manage to do comprehensive items. Hopefully. So wait a bit, someone is calling me.
Walisema kwamba kitu cha kwanza kina ambacho cha kina ilikuwa ni kwamba ule mswada wa kifedha wa 2024 tulio mbali. Hiyo ndio ilikuwa the main thing. Na ilikuwa ni kwamba hatutaki ile inaitwa punitive tax regime. Na hiyo mambo yote
okay, it's fine now. So let me jump direct.
Wale vijana wakati baada ya kushirikisha serikali yale matakwa yao yote karibu yote takriban 90% yote yanaweza kutimizwa. Kwa hivyo wewe unasema kwamba Rais William Ruto hasikizi na yeye ndiye mkubwa wa Kenya. Kwa kwanza ni uongo, ningependa kusema hivi. Jambo lingine ni kwamba yale masharti ambayo tunaona sasa yanasukumwa yanasema ndio masharti na tunaambiwa ni masharti.
So okay, now I'm done. I don't know why my phone keep on anyway, but I hope it is clear on your side. That is the most important item. So we talk about time series analysis. In most cases, we tend to analyze, refer to data that has been gathered and arranged over time, over a period of time, regarding issues such as population, sales, and profits. So in most cases, we talk about time series data. We refer to data which have been gathered and arranged over a period of time, regarding issues such as population, sales, or profits. So let us write it down. So this refers to data that has been gathered, and arranged over time, and arranged over time, and arranged over time, regarding issues such as population, sales, and profits. Now we talk about time series data. So this can be any data that has been arranged in a particular manner over time, and that data might relate to population. It can also relate to sales, or it can also relate to profits. It might also relate to profits. Okay, we continue. Continue and say importance of time series. Importance of time series. Importance of time series, number A, we can talk about it helps in understanding. Past behaviors. It helps in understanding past behavior. You can say it helps in predicting future behaviors. So it helps predict future behavior. Then we can say it helps in removing. It helps in removing seasonal variation. So it helps in removing seasonal variation. It helps in removing seasonal variation. So those are the three important of time series that we can talk about when it comes to time series analysis. When it comes to quantitative analysis, I mean, so those are the three importance of time series data when we talk about quantitative analysis. So number one, it helps in understanding past behavior. Number two, it helps in predicting the future. Number three, it helps in removing seasonal variation. Now, let us talk about the components.
Lakini kuna sababu za kuridhisha za kuendelea na maandamano hayo. Sasa ni kweli hilo ndilo swali umenijibu. Unajua hii si maneno ambayo labda kuna mtu fulani ati anasukuma hivi maandamano inakuja.
We can also add this one as another definition. So another definition of time series which we can add here is a very good one.
Ilianza na ni kwa nini inaendelea. Wameeleza vizuri vile ilianza.
You have another definition of time series and you can say it's a set of data. It is a set of data. It's a set of data that are successively corrected. That they are successively corrected at regular interval. At regular interval of each time of occurrence of each time of occurrence. This one is a very good one. So it's a set of data that is successfully corrected at a regular interval upon each time of occurrence. For example, sales data. So when you correct our sales data from January to December and we have the figures, then we can call it a time series data. So examples, we can talk about production. Another examples apart from population, sales and profits, we can talk about production. We can talk about monthly production of a company. Monthly production of a company. We can also talk about day sales in a medical store. So we can talk about day sales in a medical store. We can also talk about amount of rainfall, amount of annual rainfall over the period of time. So amount of rainfall over the period of time can also be a good example of time series data. And then another example, we can talk about money deposited in a bank on various working days. So money deposited in account on various working days. So benefits or the important, understanding the past behavior of a variable and is able to determine the direction of the periodic fluctuation. That one is under past behavior. So time series is able to understand the past behavior through what? Determining the direction of the periodic fluctuation, and also predicting the future. So predicting the future behavior, all those relate to the behavior. Number two, determine the impact of various factors influencing variables. So it also helps. So another one, let us give another example, another importance as number D. So another importance we can add here, it helps. So it helps determining. It helps determining. So it helps determining the impact. The impact of various. So it helps determine the impact of various factors influencing different variables. Different variables, which then facilitates the comparison, which then facilitate their comparison, which then facilitate their comparison. So tumesema it helps in determining the impact of various factors influencing different variables, or various factors influencing various variables, which then facilitate their comparison, which then facilitate the comparison. That one is fine. That one is quite fine. Do we have any other important of time series which we can think of? So any other factor? So I think there's no any other factor. Demonstrations, protesting, picketing. Let us talk about components. Component of time series. We have 4 components of time series. In other words, is 4 of them. So one of the components we call it the secular trend. So one of the components is the secular trend. We have the seasonal variation. We have the cyclical variation. And the last one we have the irregular variation. That's when you have the irregular variation. Those are the 4 components which we shall explain them. Which you shall explain them in detail. So which we shall explain them in detail. Okay. So tumesema number D, it helps in determining the various impact of various factors influencing different variables which facilitates in their comparison. So let us talk about components of time series analysis.
Get the whole story. Secure your future with Haba Haba.
So component of time series.
Whether you're a Boga or the border
components.
Kali Artisan, NSSF has you covered. Dial *303# to join now. Save now with as little as 25 Kenya shillings daily, with the option of withdrawing 50% of your contribution with interest after consistently contributing.
So let me set them. So we have the secular trend or secular variation.
NSSF today.
Number one,
NSSF. Growing you for good.
secular trend.
Je, unajua unafaa ku-update tokenita yako? Steps ni mbili tu, kureset na ku-update.
Or
Hawa watakutumia message kuna code alafu
secular variation.
tokenita yako.
So divided by T. So divided by T. We have seasonal fluctuation. Seasonal fluctuation divided by or variation. Or variation divided by S. Then we have cyclical variation. Cyclical variation divided by C. And then irregular stroke random variation. So random variation divided by I. Divided by I. So those are some of the examples of
We are forging the next generation of media moguls, driving economic transformation and shaping the future. Introducing our flagship program.
those are some of the example of time series components that we are going to discuss them.
Production of photography to digital
That we are going
about action. Our hands-on approach means you will
discuss them.
producing and innovating from day one. But we don't stop at technical skills. We empower you with life and entrepreneurship skills. And with Standard Group, home to KTN, Radio Maisha, Spice FM, Vibes Radio, the Standard newspaper, and more. You have unparalleled access to real-world experience and opportunities. Enroll now and ignite your journey in the heart of the creative economy. Visit www.salanta.ac.ke or call
Okay.
468 for more information. Standard Talanta Academy, unleash creativity.
So I'll go to the other side. So I start with the first one, secular. So talk about secular trend. So secular trend. Now I know about secular trend. So in this trend, in most cases, there is a general tendency of time series data to increase or decrease or to stagnate for a long period of time, for a very long period of time. That one is secular trend. So let me write it here. Tuanze na kwanza secular trend. Secular trend, you can say. So this is the general trend. This is the general trend. The general trend is not trend. General tendency of time series data. Of time series data to increase or to decrease or to stagnate. Or to stagnate during a long period of time. during a long period of time. During a long period of time. So we add something. We say the pattern might be linear or nonlinear. The pattern might be linear or nonlinear. The pattern might be linear or nonlinear. Nonlinear. It is linear. It is linear when it is linear with the series values. When the series values are concentrated on a straight line. Are concentrated on a straight line. On a straight line. On time plot. On time plot. So it is linear when you plot this item on a time plot and it becomes a straight line. It becomes a straight line. Now, time plot is known as graph. So time plot is known as graph. So time plot is known as graph of time series of time series of time series. So time plot is known as a graph of time series values of time series values against different time points. Against different time points. Against different time points. Against I mean different time points. So that's all about the time plot. The time plot is a graph of time series against different time plots. So meaning when we are plotting our equation, our independent variable is always the time. So time is what we'll be plotting against. So there are the dependent variable, which depends on the time, might be different. For example, we can have population as dependent, sales as dependent variable, and so on. So and therefore that one is a time plot in most cases because time is always part of time series. So let's sketch an example of an upward movement and downward movement. So just a sketch. So we have y, we have x. Now, this is an example of an upward movement. upward movement hapo. So that was an example of upward movement. Then you can have another one. So we have y and x. This is a downward movement. That's a good example of a downward movement. So when we plot against, remember x is our time, but y will depend. And in that case, when we sketch an upward movement, that's how it will look alike. And then a downward movement, we also look in that way. That one is fine. So that one, in most cases, you just put it on a graph. So haina mambo mingi. So that's all about the secular trend. We can go now to the next one, seasonal fluctuation or variation, which is donated by S. Which is donated by S. So I think I will move to the other side. So just allow me to go to the point of origin. Allow me to go to the point of origin. So where we started from. Okay. So allow me to do away with this one. Allow me to do away with this. Let us talk about number 2, seasonal variation. The seasonal variation, you can say. So a periodic movement, so refers to a periodic movement, refers to periodic movement, where the period is not long more than, where the periods, is not longer than 1 year. Is not longer than 1 year. So for secular trend, we saw that the period is more than 1 year. So we have either decrease, or where the values tend to stagnate, but for more than 1 year. In this case, when we talk about seasonal variation, then the period is less than. So the period is less than 1 year. The period is less than 1 year. A bit, let me use this one to just allow me kidogo. So for the periodic movement, where the periods is not longer than 1 year. Okay, let's see what we can add. Let me find if there's something we can add. Concerning that one. So hapo ni clear kama mbona leo iko hivyo. Hapo so tunasema this refer to the periodic movement where the period is not more than 1 year, where the period is not more than 1 year. Na tumesema this is a bit tofauti na the secular trend. Na tumesema kwa secular trend, in most cases the periods where we have either decrease, so we can have where the values are either increasing or decreasing, or maybe the values tend to stagnate over a period of time, but that period is more than a year, or for a very long period of time, or for a very long period of time. Now, for seasonal, so this one is where our period movement is not longer than 1 year. So we can have example, i.e., let's give examples. We can talk about data on climate, data on climate, such as rainy season, sales during Christmas period, sales during Christmas period, are good examples. So these are good examples of seasonal variation or fluctuation kind of a scenario. You can say, you can add these variations repeatedly occurs during a corresponding month or period of successive years. So a period of successive years ni kumaanisha inaweza kuwa we have a lot of sales during December, and that sales also continue from January. So we might have a lot of sales in December. So in December we have a lot of sales in food because people are eating a lot. Then in January, we can have a lot of sales on things to do with school. So we can have a lot of sales on pens, uniforms, books, those stationery items. So we can have two successful data for food and other stationaries between December and January. So, but those items just occurs at a limited period of time, and then zina disappear. Then zote nazikuje. So even for rain, unaweza kuna mwezi kuna mvua, kuna mwezi zingine hakuna mvua during the year. So all those are successive occurrence which occurs. Number next, let's talk about cyclic variation. Cyclic variation. Cyclical variation. And what is cyclical variation? We can say so we can say fluctuation with a period more than 1 year. With a period more than 1 year. So hii ni tofauti kidogo na ile ya kwanza, the trend. The first one, where we have either the data increases or decreases or remains stagnant for a very long period of time. For a long period of time, it can be more than 1 year. That one is fine. But this one is specific for a period more than 1 year. For a period more than 1 year. That one is for cyclic. So you can say so it is where we have more than 1 year oscillation or wave-like fluctuations about the trend line, in time series. And you remember the trend line. So you lazima ukumbuke. Ukumbuke the trend line is a linear equation. The linear straight line given by y is equal to a plus bx. Now, ikiwa inakaa hivi, so we have y and we have x. Now, this is our trend line. So this is escalation. So it inaenda hivyo. This one is what we call the cyclical. So we have the boom, the recession, the boom, the recession. So it is it tunakuwa na peak period, then tunaenda kwa recession, and so on. So that's all about the cyclical variation that we can think about. Okay. We move on. Tuende kwa mwingine wanamuitaje? Wanamuita irregular. So they call them irregular. So let us talk about the irregular. So for irregular, variation are completely unpredictable. So we cannot completely predict the variation. In this case, it is very, very hard to predict the variation. That one is called the irregular. So irregular. So irregular. So irregular variation. So irregular variation. Tunasema. So variation are completely unpredictable. So this is where variation are completely unpredictable. So this is where the variation are completely unpredictable in character. For cyclic, because the trend is somehow predictable, but for this one, the trend tends to be unpredictable somehow. So let us see how we can plot it. So if we decide to plot it, then this is how it will look like. So we have y, and we have our x, then we have our trend line. But now we can have something like this one. So it is unpredictable. So this is what we call the irregular. That is what we call the irregular trend. That is what we call the irregular trend. So we cannot easily predict in that kind of a scenario. So it is irregular. So we can also add the definition of the word irregular variation. So we can also add another definition for irregular variation. So we can also add another definition of irregular variation, and we can say, but the definition are dated. These are variation caused by sporadic events. So when we talk about sporadic events, we are talking about unpredictable events and events which you cannot predict, i.e., floods. So we cannot tell if we shall have floods, strikes, disaster, and wars. So these are some of the sporadic events. Remember, another name of irregular variation is random variation. So this is another name. So another name, also known as random. So irregular variation also called random or erratic variation or erratic variation. So those are the 4 components of time series. So that the first one, we say the trend, and this is where we have either increase or decrease, or where the data remains stagnant for a very long period of time. And then number 2, we have said seasonal variation, and tumesema periodic movement of data for not more than a year, so that movement of data, but not more than a year. Then you have the cyclic variation, and this is where we have more than 1 year oscillation or wave-like fluctuation of data, or where the data fluctuates more than a year. Then the last one is the erratic or the random or the irregular variation. And this is the where variation are completely unpredictable in character, or the variation which are caused by sporadic event. Time series analysis. So time series. So time series analysis. So that one is our subtopic. Before we continue, so time series analysis, and you can say this is an act of analyzing, interpreting the series data. So this is an act. This is an act of analyzing and interpreting. So the act of analyzing and interpreting time series data. So this is the act of analyzing and interpreting time series data. So it can be said to be an investigative method into the time series component. So we can also say it. We can say that the time series analysis can also mean an investigative method into the time series component. Remember, we have said the time series component are the trend variation, the seasonal variation, the cyclic variation, the irregular variation. So when we investigate all those 4 components of time series, then we'll be doing time series analysis. It is also referred to as decomposition. So you can also say it also called decomposition of the time series. Decomposition of the time series data. Also called the decomposition of the time series. So also called the decomposition of the time series. So let me go to the other side. Okay. Let us see. Now, we can say The first step of time series analysis is to draw the time plot. That is very important. So the first step of time series analysis. Time series analysis is to plot is the drawing of the time plot of the time plot and we have to define what is time plot. So we said it's a graph which represent the time series data. Na tukasema it's a graph which represent the time series data. So the first step. So the first step, I'm going to put the word first. Anybody imagine the word first? So the first step of time series analysis is drawing the time plot. And we said that the time plot is a graph which is used to plot the time series data. So it is a graph which is used to plot the time series data based on period. So the keyword is the word period, based on period. So the time plot is a graph which is used to plot the time series data based on the time period. So the keyword there is the word time period. Now, let Y be the series by convection be the series by convection series by convention, not convection, convention. Now, this one is to let Y be the dependent variable. So let Y be series by convention, or let Y be the dependent variable, and T, S, C, and I as component of time series. Remember this component gani? T means the trend variation. S means seasonal variation. C means cyclical trend. Then I means irregular trend. Hii to define hapa mwisho. Irregular trend or the erratic trend. So that will be the series by convention, and T, C, S, and I be the component of time series. And then we say, using the above component, we can analyze the time series data So using the above component, we can analyze the time series data using two models below. Using the two models below. So number A, talk of additive model Number 2, multiplicative. Model. We can talk about additive model. Number 2, additive model. Now, we start with each one. Let me see. Go to sawa. Now, let's talk about estimation of variations. Estimation of variation. Estimation of variation. So estimation of variation. So estimation of variation involves estimation of variation involves the use of original time series data. The use of original time series data. Time series data. So estimation of variation involves the use of the original time series data and the trend obtained. And the trend obtained. And remember, we said when we were doing the regression, we can only obtain the trend using the regression analysis. So estimation of variation involves use of the original time series data and the trend obtained. How do we get the trend? So the trend is obtained by finding the value of A and B to get the trend line or the trend equation. That one is for regression, but we need that one. So 2 models are used. So we can say 2 approaches are used. And here so we have the additive and we have multiplicative model. Multiplicative model. So 2 models are used. We have additive and multiplicative. The word additive means addition, from the word addition. So additive model from the word addition. So this one, you just know it's from the word addition. Then multiplicative model from the word multiply. So multiplication from the word multiply. We start with the additive model. Let us start with additive model. We start with additive model. So we start with the additive model. So let us move on and see if we can add some item. Then we proceed to the other side. Now, this one is very important because in most of the questions comes from additive and multiplicative in most scenarios. So let's start with additive model. Additive model. So let us just do the steps. What in a new let me go to a new. Let me not squeeze so much. Now, so I think hapo iko possible, inaonekana. I think hapo itakuwa sawa. I think that one is visible from that point. So I'm saying we need to come up with the steps. So give me a moment, I'm coming back. So let's continue. So additive, we are talking about additive model, and you want to give the procedure. So additive model. Okay. Now for additive model, it involves adding together the time series component. So let me give you a definition before we go to the steps, because you might find in an exam a requirement for you to define okay. So additive model. So we talk about additive model. You can say it is a model which involves adding together the components of time series data. Data. So it's a model which involves adding together the components of time series data, i.e., so this one. So our y, remember we said our y was our series of conversion, which is given by, we're supposed to take the cyclic trend, we add the t, we add the c, and we add the I. Where S is the secular trend, this one is, we have a seasonal variation, this one is seasonal variation, this one is, another one is what? We have cyclic, we have erratic, this one is, we have seasonal and trend. So seasonal variation, you have the trend, you have the cyclic, and you have the erratic. So by adding together the component of time series, so this one is seasonal variation, this one was the trend, the secular trend, the secular trend variation, so by adding them together we shall get what we call the component of the time series data. So before we go to the steps, we can also add and say, I think iko sawa. Let's go to the steps. I think data iko sawa hivyo. So where y is our time series data or the dependent variable. This one is the seasonal variation. This one is the trend, the secular trend. C, the cyclic variation. I is the irregular variation or the erratic. Steps. So steps. So step number 1, which is very important, is arrange the original. So arrange the original. Data given time series y, time series y. So that is step number 1. So in short, the data we are talking about, the original data is our y. So in short, the original data is about population, then the data of population is our y. If the original data is about cells, then the original data is the time series data, which is y. Number 2, the trend. To be, so the trend to be placed next to the column, next to the column. Which column? The column of the y, to the column of the y. So the next time is come up with the trend data to be placed next to the column of the y series. Number 3, obtain the seasonal variation. Obtain the seasonal variation. So obtain the seasonal variation. How do you get the seasonal variation? So obtain the seasonal variation. How do we get it? Now we make S our subject formula. So how do you obtain it? By making S our subject formula. So S will be equal to what? So kila kitu kuja side S ibaki huko. So itakuwa Y minus C minus I minus C minus I. So obtain the seasonal variation, which is our S in this case. Now, but we need to make some assumption here. We need to make some assumption here that assumption is that C plus I is equal to 0. So C plus I is assumed to be equal to 0. So for example, eka C hapa, C ukileta hapa, na I ukileta hapa as 0. So huyu plus huyu ni 0. So kumaanisha huyu hata ukiadd au wawili, the answer will give you 0. So whichever ikuwe ni minus ama ni add, ama hapa, or you use this one, hapa juu. So if you assume that C plus I is equal to 0, then kumaanisha our original equation ikiwa hivi hapa original, Y is equal to S plus T plus, so C plus I ni 0. So kumaanisha our S equal to Y minus T. So meaning, so if you assume C plus I is equal to 0, then S will be equal to Y minus T. S and I will not be there because C plus I will be assumed to be equal to 0. Therefore, our final seasonal variation is Y minus T. Number D, obtain the average. Obtain the average seasonal variation. So obtain the average seasonal variation for each period. Period. So obtain the average seasonal variation for each period. This is known as seasonal index. SI. So ukiambiwa kwa mtihani you define what is seasonal index, you say this is the average of the seasonal variation. So that was step number 4. We obtain the seasonal index, the average seasonal index. Then number next, check whether the seasonal index is balanced. So check whether the seasonal index is balanced. So hapa hivi lazima ukumbuke that for additive model, the seasonal index must be equal to 0. For additive, it must be equal to 0. But for multiplicative, it must be equal to 4. So check whether the seasonal index is balanced. So i.e., how do you know if it is balanced? I.e., we say add the indices obtained, and the indices obtained, and if equal to 0, and if equal to 0, it is balanced. It implies balance. So that one is for additive. So check whether the seasonal index is balanced. How do we know? We add the indices obtained. So if we add them together and the value becomes 0, then we shall conclude that it is balanced. If not equal to 0, then it is not balanced. So if not equal to 0, is not balanced. If not equal to 0, then it is not balanced. Now, how do we do it? How do we make it balanced if not equal to 4? We adjust. So the last step is to adjust. So if not equal to 0, then we adjust. So adjust the seasonal index. So adjust the seasonal index if not equal to 0. Sijui kama nimetoka kwa board. So adjust the seasonal index if not equal to 0. So adjust the seasonal index if not equal to 0. So how do we adjust it? Now, IE. So how do we adjust it? IE, divide the difference. Divide the difference. So divide the difference by the number of period. By the number of periods. And then add. And then add. And then add or subtract. And then add or subtract to the seasonal index. The seasonal index. And then add the seasonal index. To make the sum 0. To make the sum 0. I think we can do a question for additive model. So those are the steps which we can use when it comes to additive model. So adjust the index. So adjust the seasonal index if not equal to 0, i.e. divide the difference by the number of the periods, then add or what? Subtract. So then add or subtract. Hapo tumefanya makosa. Then add or then add. Mimi nakuja hapa. So then add or subtract to the seasonal index to make the sum equal to 0. That one is fine. Let's go to one of our past paper and see. So we can open the past paper. So nimepata moja. April 2022. April 2022. So April, I think I just do away. So April 2022, question number. So April 2022, question number 7, I think. Question number 7. April 2022, question number 7. So April 2022, question number 7. So hopefully itatoshea without stress. Now I want to show you the format that you shall need to come up with. So we are talking about additive. So this one is 3/4. That one is the best part of it. So I don't want to complicate items. So ndafanya ikwe. So sitakuwa nimeweka information mingi. The important part, we come up to the final answer. Now, so April 2022, question number 7. So for the purpose of itabidi nimetumia might use a ruler ndio itoshe vizuri. Now this one is for 3/4 moving average. So we are doing for 3/4 moving average. Moving average. So it's for 3/4 moving average. So we are doing for 3/4 moving average. So let me arrange it. Now, so the format, sitaki ikuwe tena mrefu sana. So nita avoid the column of the years and the quarters. Ningie tu kwa direct. So in this question of ours, what was the sales? What was the not sales? I mean, the table, the data belongs to which kind of a scenario? Is it for population? So the table below shows the quarterly profits. So these are profits of Kahawa Limited in millions for year 2019 to 2021. So the question it is for 3/4 moving average as indicated. So I shall deal with the 3/4 moving average. So mean as a unit profits. So mean as a profits. Profits. We talk of profits, of which our profit is our Y. Then 3/4 moving average. So we have 3/4 moving average. And then variation. So this one represents T in this case. Then seasonal variation. Seasonal variation, which is Y minus T. And then we can talk of, I think those zimetosha for now. I think those column, they are enough for now. So remember, tukifanya for quarter, the item might be a bit different. But for 3/4, I think those is quite enough. For 3/4, those will be enough. Let me see if I have a 3/4 here. I think Sina. I think Sina. So Sina, yeah, that one. But so let us come up with the figures to make it easier. So I hope itaonekana mzuri because this figure ni mingi. So we have 23, 32, 27, 21, 27, 35, 32, 24, 31, 43, 40, 29. I hope sijaruka hata moja. Hopefully. So acha niweke hivi ndio ikuwe a bit rahisi kidogo kuonekana. Tukiweka hivyo sisi tutakuwa tunaona kile tunafanya. Na I hope inafika hadi hapo. I think that one is enough. Haya. Naweza pia huyu. Ito is 27, 21. Wacha nijaribu kutumia mkono. Hii inakuwa slow sana. But I hope inaonekana. So those are the figures. So the first thing we find the 3/4 moving average. So the 3/4 moving average, we start with the first three. We start with the first three. Now, with the first three, let me use another pen to differentiate. Let me use another pen to differentiate. Now, for the first three, we find the average of the first three. So what will be the average of the first three? For example, 23 plus 32, the first three. So 23 plus 32 plus 27. So the total is 82, but we need the average. How do we get the average? So tulianza na wao watatu. So tukianza na wao watatu, tuna add wote, then divide by 3. So 82 divided by 3, it is 27.33. Now 27.33 is the average. So hapa 27.33. So katikati ni wapi ya tatu? So tuko na 23, 32 na 27. Katikati iko kwa 32 kwa sababu 23 na 27 katikati ni 32. So ukichukua 23 plus 32 plus 27 divided by 3, the figure ni hiyo. Tunamalizana huyo, the first 3. Then we have the second 3. The second 3 kutoka wapi now? Kutoka kwa 32 sasa. Tunachana 23. So kutoka kwa 32 plus 27 plus 21. So the next 3. So tunatoa huyu wa kwanza. So tunaenda wa pili. So 32 plus 27 plus 21, which is 80 divided by 3. which is 26.67. So 26.67. Tukishamaliza huyo, tunaenda the next one. The next one is 27 plus 21 plus 27. 27 plus 21 plus 27, which is 75. Divided by 3, 25. 25.00. Jitumeka into two decimal place. Next ni hapa. Now, even now, hakuna haja consider the first one kama hii inaweza kusumbua. Unaangalia kama hii ya kwanza katikati yao ilikuwa inaanza ni 23. Na ya pili tunaanza nayo ni 32. Na ya tatu tunaanza nayo ni 27. So ya nne itakuwa ngapi? Tutaanza na gani? Obviously tutaanza na ngapi? 21. Ndio iko plus 27 plus 35, katikati yake tukuje hapo hivyo hivyo. So 21 plus 27 plus 35 divided by 3, which is 27.67. Aya, kwa 35 katikati ni 35, so tunaanza na 27 plus 35 plus 32 divided by 3, which is 31.33. Aya, next katikati ni 32, so tunaanza kwa 35 plus 32 plus 24 divided by 3, 30.33. Next ni 24 ndio katikati, so inaanza kwa 32. So 32 plus 24, 32 plus 24 plus 31 divided by 3, which is 29.00. Then kwa 31 tunaanza kwa 24 plus 31 plus 43 divided by 3, which is 32.67. Then tunaenda next 31 plus 43 plus 40 divided by 3, 38. Then ya 40 tunaanza kwa 43 plus 40 plus 29 divided by 3, which is 37.33. The first one, the last one and the first one for the quarter hainanga. The first one and the last one for the quarter hainanga. Now this is the column. Step number 2 alikuwa anasema find the t next to the which column? Next to the y. So the t we was step number 2. Na kwa swali yetu walikuwa wanauliza nini? Let's go to our question. Our question wanauliza part A, the quarter moving average. The hiyo. How many marks? 6 marks. So this one is the quarter moving average. Let's go to the next one. Let's find the variations. So how do we get we find the variation? So let us find the variation. So the variation is y minus t. So kama kawaida, the first one haina, because the figure here ni empty. So kama figure ni empty hakuna, na pia hapa figure ni empty hakuna. So 29 minus something haitakuwa. So this one you ignore, and the first one. So tunaanza na kwa 32. So 32 minus, so it is y minus t. This one is our y, and this one is our t. So 32 minus 27.33. So what would be the figure? So find that one. So 32 minus 27.33, 4.67. 4.67. 27 minus 26.67. 0.33. 21 minus 25 minus 4. This one is minus 4. 27 minus 27.67 minus 0.67. 35 minus 31.33. This one is 3.67. 32 minus 30.33. 1.67. 24 minus 29 minus 5. 31 minus 32.67 minus 1.67. 43 minus 38, which is 5. Then 40 minus 37.33, which is 2.67. So that one is how to get the seasonal variation. That is how we are supposed to come up with the seasonal variation using the additive model. Part B, 4 marks. Part B, 4 marks, they're here. So this is how you come up with the seasonal variation, which is y minus t. Those are the figures, 4 marks. How to come up with the seasonal variation. Then let's go to the last part, which is part C, forecast the figure for 2022. You want to forecast the figure for 2022. But for what? For adjusted profit. For adjusted profit. So you are supposed to forecast the figure for 2022 for adjusted profit. So that one in short, you find the decentralized figures. So in short, that you find the decentralized figures. So let us see if we can find them. Now, for us to get to find the decentralized figure, then we need to come up with something. So there's something that we need to come up with. So hopefully hapo itatoshea hapo chini. So we need to come up with a table. Hopefully that table itatoshea hapa chini. Kwa sababu hii ya mwisho ionekane mzuri, let me put it in that form. So we need to come up with this, with a table here. Summary of the seasonal variation. Summary of, so this is another table. Before we do part 4, we need to come up with this one. Summary of the seasonal variation. I'm a schedule. Schedule. Summary of the seasonal variation. Schedule. And this table, iko na years. Iko na years. Here you have quarter 1, quarter 2, quarter 3, quarter 4, and you can say totals. You can talk about totals. So quarter 4, quarter 3, quarter 2, and quarter 1. So another table. So we had which year? Let me go back to the years. We had which year from 2019 to 2021. So 2019, 2020, 2021. Now, hopefully that will share. So after hapo, in abbreviation, we need to find the average seasonal index. Number 1. We need to come up with that one. You come and kwa laini. Average seasonal Index nimeroka kwa line. So bado. So average seasonal index. Then so tukasema average seasonal index should be equal to what? To 4. If not equal to 4, then we need to do adjustment. So kama itakuwa to 4, let's just put it in case adjusted seasonal index. So for each quarter. So we don't need this total, and this total. We only need to which total? The total for the adjusted. So tuanze na 2019. 2019 quarter 1 hapa. So unakuja na hapa. So remember the first 4. 1, 2, 3, 4 mpaka hapo. 1, 2, 3, 4 in 2019. Then kutoka hapa 1, 2, 3, 4 hadi hapo ni 2020. Then kutoka hapo hadi hapo ni 2021. So tuanze na 2019. So this one is quarter 1, quarter 2, quarter 3, quarter 4. Then quarter 1, quarter 2, quarter 3, quarter 4. Tena quarter 1, quarter 2, quarter 3, quarter 4. So each year iko na 4 quarters. So quarter 1 hakuna kitu. So tunaweka dash. Let me use a different pen. So quarter 1 2019 hakuna. Quarter 2 4.67, then 0.33, then minus 4. Tumemaliza quarter 1. Quarter 1 2 3 na 4 ya 2019. So tuingie 2020 quarter 1 negative 0.67, 3.67, 1.67, minus 5. Then quarter next, quarter 2021, quarter 1, naanzia hapo. So which is minus 1.67, 5, 2.67. We don't have any figure here. Let us find the average. So find the average. Find the average. Now, remember when you find the average, you divide it with the number of items. So kama hapo the number of items ni 2, hapa hakuna kitu, hapa hakuna kitu. So the number of items hapa ni 2. So for example, hapo tunasema minus 0.67 plus minus 1.67. But the number of items ni ngapi hapa? So tuko na 2019, 2020, 2021. So ni 3. Lakini the box which iko na number ni only 2. So you divide by 2 kwa sababu ni 2. Hii haina kitu. So divide by 2. Negative 1.17. Huyu 4.67 plus 3.67 plus 5. Now divide by, so wako watatu, so divide by 3. So divide by 3. So itakuwa 4.4. Take it into 2 decimal place. Let us put it in 2 decimal place. 4.45. 4.45. So we put it. So hapa divide by 3 because number of items ni 3. But kwa box zote ziko nayo. Hapa box ni 3 lakini moja haina, so divide by 2. Hapa 0.33 plus 1.67 plus 2.67. So hapa number of box ni 3 na zote ziko na figure. So zote ziko na figure, so divide by 3. 1.56. Then pale ni minus 4 plus minus 5 divided by 2. Itakuwa ni minus 4.5. Now we add them together. The answer must be equal to 0. So minus 1.17 plus 4.45 minus 1.65 minus 4.5. The answer must be equal to 0. If not equal to 0, then we need to adjust. So to say minus 1.17 plus 4.45 plus 1.56 minus 4.5. The answer is 0.34. This one is not equal to 0. This one is not equal to 0. So we do what? We adjust. So we adjust. So do we adjust? We take the figure, which is 0.34. We divide with the number of periods or the number of quarters. So we had how many quarters? Quarter 1, quarter 2, quarter 3, quarter 4. So each year had how many quarters? Quarter 1, quarter 2, quarter 3, quarter 4. So we divided by the number of quarters. So divided by 4.
Excuse me, Walim.
Eh.
Quarter 2, why is am I getting different from you guys?
Quarter 2, umepata ngapi?
4.67 plus 3.67 plus minus 5. We divide by 3, right?
So 5, oh, 5 ni minus.
Yes, or, is it minus?
Oh, this one is minus.
Yes, it's minus 5.
So, oh, minus 5. Then divide by 3.
By 3.
So inakuwa 1 point.
1.11.
Then we add them together. So zile za huko juu zote ziko sawa, zile tulikuwa tukiminus. So make sure ziko tu sawa. Hizi za huko juu. Tusikie kuna mahali tuli minus vibaya. Sawa sawa. So acha ni hebu let me go back hapo nione. Sawa sawa. Na hizo zingine ziko sawa, hizi zingine tukiadd. So hapa this one is 5, positive 5. This one hapa
Negative.
so we shall consider hapa ni positive 5. This one ama mimi naona aje. Hebu turudi hapa. So tulisema hapa ni hakuna figure, so hapa hakuna figure. 4.67 iko sawa, 0.33 iko sawa, minus 4 iko sawa, minus 0.67 iko sawa, 3.67 sawa, 1.67 sawa. Oh, this one is minus.
Minus 5, yes.
Minus 5 iko sawa. Then minus 1.67. Oh, this one is positive. This one is positive 5. Then 2.67. See if iko sawa.
Yeah.
So let us change this one. We correct them. Vizuri. Let us correct them. Tuanze na wa kwanza. So ya kwanza, let us say minus 0.67 plus minus 1.67. I hope unapata negative 1.17. I hope that one is the answer hapo. I will 4.67 plus 3.67 plus 5 divided by 3, 4.45.
Yeah.
So I think hapa shall confirm.
Yeah.
It's positive. The
Mm.
positive ndio hapa. Positive 5. 0.33 plus 1.67 plus 2.67 divided by 3, 1.56.
Yeah.
1.56. Then minus 4 plus minus 5 divided by 2 minus 4.5.
4.5, yeah.
So itakuja hiyo minus 1.17 plus 4.45 plus 1.56 minus 4.5. 4.5. 0.34. Now, this figure is not equal to 0. So we do what? We adjust to make it positive. Now, the process of adjustment is called the normalization factor. Let me just note it somewhere in case you find it in an exam. Normalization. Okay, let's talk about normalization factor. So normalization factor is a factor which is used to adjust the average seasonal index if not equal to 4. So normalization factor is a factor, and you hear 0.34 divided by 4, that factor. So it's a factor which is used to adjust the average seasonal index if not equal to 1. If not equal to 1. So if not equal to 1. So naweza sema, acha nijaribu kuweka hapa. Say it is a factor which is used to adjust. Yes. To adjust average seasonal index if not equal to 1. Not equal to what? To 0, not 1. If not equal to 0. So tumesema afika hapa lazima ikuwe 0. So it is a factor which is used to adjust the average seasonal index if not equal to 0. So a factor which is used to adjust the average seasonal index. So SI means seasonal index, which is used to adjust the seasonal index if it is not equal to 0. And in this case, we need to calculate it because 0.34 is not the same as 0. So 0.34 divided by 4. Itakuwa 0.0? 0.085. 0.085. Now, alafu akatuambia the last process, we either add or subtract to this figure. So do we add or subtract? Let us try one of them. Let us go with what? Let us try by adding. So tuanze na ya kwanza, negative. So tuanze kwa hii. So we either add this factor, we either add or subtract. So let us go with addition. So minus 1.17 plus 0.085. So figure hapa itakuwa ngapi? Ndio figure itakuwa minus 1.085. So tumesema tuna add. Then 4.45. I mean, sorry, 4.45. Itakuwa 4.535. Then 1.56 plus 0.085. 1.645. Then minus 4.5 plus 0.085. Itakuwa minus 4.415. Then we add them together. Tuone kama itakuja 0. So minus 1.085 plus 4.535 plus 1.645 minus 4.415. Imekata. Haijakuja 0. Hebu tuone tena. So minus 1.085 plus 4.535 plus 1.645 minus 4.415. Inakuja 0.68. That one it is even worse. So mbona imekata? Divide by 4. If we divide by 4, minus 1.17 minus 1.085, 4.45 plus 0.085, 4.535, then 1.56, 1.645, then minus 4.5, minus 4.415. Haikuji. What if we subtract? But I think itakuwa to the same. What if we subtract? Let us minus. Let us try and subtract. Just try working hapa chini. So mbona imekata? So minus 1.17. So minus 0.085. Let us try this 1.255. 4.45 minus 0.085. 4.365. Acha tuone hii kama itakubali. 1.56 minus 0.085. 1.475. Then minus 4.5. minus 0.085 minus 4.585. Look at easy. That one, eh? Minus 1.255 plus 4.365 plus 1.475 minus 4.585. So this one is correct. This one at a 0. So you be uko na minus. So minus I think will be the best way, not adding. So pale kwa our nini, in our nini pale nyuma, our steps, anyway we subtract. But in an exam, ukiona moja ifanye, you try another one, either by adding. So we either add or subtract. So inakuletea 0, you use that one. So inakuletea 0. So this one becomes our adjusted. This one becomes our adjusted seasonal index. So that one becomes our adjusted seasonal index. Now the question require nini? So let us finish this question. That will be the end of our question today. So the question required us to do what? To do so we have to forget the adjusted profit. The adjusted profit for which quarter? 2022. So let's adjust this here. So adjusted profit. So you can also call it. You can also call it the seasonalized. The seasonalized profit. That's another name. How do you get it? So you use, so the formula is y divided by adjusted seasonal index. So ametuambia which year? 2022. 2022. So we have quarter 1, quarter 2, quarter 3.
William, what is that you've written? Adjusted profit D?
Adjusted profit or inaitwa the seasonalized. From the one seasonalized.
Sawa.
So the word adjusted can mean the seasonalized. So profits. So hapo hiyo imeonekana. So for you to get the adjusted profit, you take your y, you divide it with the adjusted seasonal index. Now, according to the question, wametupatia which quarter? Quarter 1, quarter 2, quarter 3, which is, so we have the y for quarter 1, 35, 50, 35, 50, 47, 33. But remember we have our adjusted seasonal index. Tulipata hapa hivi chini. Now, hii formula nimekupatia hapa, hata nimefanya makosa. Because in additive we minus, we don't divide. We minus. But kama ni multiplicative model, kama tungekuwa tunatumia multiplicative, this one is for additive. Remember this one is for additive model. Additive. Tuna minus. But kama ni multiplicative, you do what? You divide, you utafanya baadaye. So because it's additive, so we minus. Now how do we do it? So we minus our adjusted seasonal index. And huu wa kwanza tulipata minus 1.2. Tusijika inaonekana. So hapo. So tulimpata as -1.22. So minus -1.255 minus, so minus 4.365, then minus 1.475, So remember, it's for each quarter, quarter 1, quarter 2, quarter 3, na quarter 4. So quarter 4 ni ngapi? Minus 4.585. So those figures ukishapata, will mark the end of that question. So we'll mark the end of that question. So 35 minus 1.255, which is 36.255, 50 minus 4.365, 45.635, then 47 minus 1.475, which is around 45.525. Then I'm sure 33 minus 4.585585, which is 37.585. So those are the figures for part number. So those are the figures for part number 3. So for each quarter. So that one marks the end of that question for April 2022. That marks the end of that question for April 2022. Now, we shall start from time series analysis. Now, not time series analysis, sorry, multiplicative model. Multiplicative model. But for what? But for the recorder still. The recorder moving average. Then we shall do later for quarter. So sasa tunafanya the recorder moving average. So kesho tunaingia multiplicative model, the recorder moving average. So still the recorder moving average. We shall give the procedure and the steps and the definition. Then we do a question for multiplicative, just the way we have done additive. So that one marks the end of this class until tomorrow.
Can you share the record of this class?
Yes.
Okay.